crib, and now we're going to be doing a lesson about binary ionic. So pull out your notes so you can be ready to write on them. You're also going to need a worksheet, and I'll pull that up in a bit, but first we're going to learn how to do this. Binary still means two, and ionic, metal, non-metal, ionic. And just like before, we're going to only write the first name, but ionic compounds do not need prefixes, okay? Do they use prefixes? No. No, they do not use prefixes. The Greek prefixes are used up at the top by binary covalent. So the Greek prefixes, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, those you have to memorize, and they're only used, memorize these guys, this is super important, for binary covalent compounds. So now they're not used for ionic. So the first thing you do is you write down the name of the first element, and this is magnesium, and this one is aluminum. And you need to make sure you memorize these elements well, because we're going to be using them so many times. I'm going to look at the oxidation chart and show you that we're still dealing with magnesium has a +2 charge, aluminum a +3. We're dealing with things with only one charge possibility. We're not dealing with all these with lots of different options at the moment. We're only dealing with the ones. We'll do with these in a minute. But right now we're dealing with these two guys. So go back to this. So magnesium, and then this is oxygen. And so oxygen, but we change the ending to "ide." So it's oxide, magnesium oxide. So this is aluminum with an oxygen again, and you change the ending to "ide." So notice I did not put trioxide or dialuminum. The prefixes are only for covalent. Prefixes are only for covalent. Now let's look at these names. Can I turn them back into this formula? I want to show you you don't need the prefixes to get this right. So I see magnesium, and it's an Mg, and I see oxide. I know it comes from oxygen, so it's just an O. And then aluminum, I see aluminum as Al, and I see oxide as an O. Well, this is not that formula, so how do I get the formulas that are over here? Well, I have to go back and look at the oxidation chart. We just saw that magnesium was a +2 and aluminum is a +3. Remember, we're putting the cation first. Cation, then the anion. The cation is the positive ion and the anion is the negative one. And if I go to the oxidation chart, I'm going to pull it back up. That's the wrong thing. There it is. Oxidation chart. Oxygen is a -2. Now it has to be a -2 here because both magnesium and aluminum are positive, so it has to be the negative charge. Another reason is it doesn't say magnesium peroxide or aluminum peroxide, so it's not the peroxide, the O2 ion, so it's going to be a -2. It can be a -1 with peroxide, and the only time it's a positive is with fluorine, so it has to be a -2, and -2 is the most common option. So oxygen at the top is a -2 for both of these. Now, what is it? Put the charges on the top. Different charges swap and drop. So these charges are identical, so they already cancel each other out. They already equal 0, which is the option, what we look, the zero-sum rule. So this is the formula for magnesium oxide. So did we get it right? Yes, we did. Now look at this one. Different charges on the top swap and drop. So the 2 comes down to here, and the 3 goes over here. I swapped the 2 over here and dropped it. I swapped the 3 over here and dropped it. Swap and drop. Notice I only take the number and not the charge. So from the words aluminum oxide, I write aluminum and oxygen. I put the charges on the top, different charges on the top, swap and drop. This is the formula, Al2O3. And that's what this is, Al2O3. So you notice I did not need the di and the tri to prove, to get the correct formula from the name. All right, now we're going to name calcium and with the iodine. So the name of this one is calcium, because all we do is write the first element's name for the first one, and that's always the cation. And the ion is iodine, but iodine becomes iodide. So calcium iodide. Now just to prove we can go backwards, I would see these words and I'd write calcium and iodine. and I'd go to the oxidation chart, and I see calcium is a +2, and then iodine is over here. It has to be the -1 because we have to have a positive and a negative. We can't have both positives. So calcium is a +2, iodine is a -1. Put the charges on the top, different charges, swap and drop. Swap and drop. And remember, if it's a 1, you don't have to write it. This is just CaI2. So you could also look at this and say, I could determine the charge by picking the charge back up and undo the swap. Okay? All right, so that's the binary ionic compounds. Next is polyatomic ions. So before we start with these, we're going to practice on the binary ionic ones. So I'm going to stop for a moment and pull up something. I pulled up naming binary ionic compounds homework. This is one of your worksheets that you should have received. If you didn't, pause the video and go print it out. So we're going to name the following ionic compounds using Roman numbers, and so we're going to, where necessary. Now, where necessary. We haven't figured out where they're necessary yet, so I'm going to go ahead and make sure the ones we do initially don't need them. So we're going to do number 1 and number 2. I'm going to skip silver and copper because I know, and iron. Magnesium oxide we just did, and aluminum oxide we just did, and calcium iodide we just did. So let's do binary. Let's do the first one, barium and chlorine. So the name of this is barium, and this is chlorine. But chlorine becomes chloride. So this is just barium chloride. I'm going to prove to you and go the other way. Look at the word. The word is barium. I write Ba. Chlorine is Cl. I would go look at the oxidation chart. See that barium has a +2 charge. Chlorine has to have the -1 because we have to have a positive and a negative. I can't have all positives, so a positive and a negative. So barium would have a +2. Chlorine is a -1. Swap and drop. So barium Cl2. That's what that was. What about this one? Okay, I want you to try this one, and then once you've done it, we will check it. Okay? I'm going to assume that you've done that now. So Na is sodium, and F is fluorine, and FluOR, fluorine becomes fluoride. Fluorine becomes fluoride. Sodium has a +1 charge, and fluorine has a -1 charge. That's why you only needed one of each of those. Okay, this one we're going to cover in a little bit, so I'm not going to continue on with this worksheet up here. Let's go down to the next page. Let's give the formulas of the following ionic compounds. All right, we're going to do number 1 together. We'll do this one and this one. And maybe number 8. And any I don't do with you, you're going to do it as homework anyway. So potassium, all right, potassium symbol is K. Sulfide, that comes from sulfur, S. And then I go look at the charges, okay, or the oxidation numbers. Potassium's a +1. Sulfur, sulfur has a +6, a +4, a +2, or a -2. So it has to be a -2 in this case because potassium is a +1, sulfur has to be negative. So write that on the chart, top, potassium and a -2. Different charges on the top. Swap and drop. Oh, drop down here and swap and drop. So K2S. That's potassium sulfide. Okay? All right, I want you to try calcium oxide. And once you do that, we'll check it. So calcium oxide. All right. So calcium is Ca. Oxide comes from oxygen. Calcium is a +2. Oxygen is a -2. That you don't have to put the 2's there. That would be wrong. You want the simplest form, the simplest ratio. So calcium oxide. All right, I want you to try barium phosphide, and I will tell you that phosphide comes from phosphorus. So you try barium phosphide. I'm going to assume you've done it. So now barium and phosphorus. And let's go look at the charges. Barium has a +2 charge right here. And phosphorus is over here. And it has a +5, a +3, or a -3. It has to be -3 because barium is a +2. So I have to use the negative with the positive. So barium is a +2, phosphorus is a -3. Different charges on the top, swap and drop. So this becomes barium 3, phosphorus 2. Barium phosphide, barium 3, phosphorus 2. I'm going to double check and make sure I didn't write that incorrectly. 3 and 2. Nope, we're good. Okay, now beryllium sulfide. Let's see if you can do that one. Pause the video and try this one. All right, I'm going to assume you did it. Beryllium is Be. Sulfide comes from sulfur. Just like phosphide comes from phosphorus. These are sulfide and sulfur are a little closer. So right now we got to go to the oxidation chart and look it up. Beryllium, Be, is a +2. And sulfur is a -2 because we have to have a positive and a negative. So that's a +2 and a -2. They already cancel. So the formula is just BeS. Okay, so that's all we're going to do in this worksheet. I'm going to pause the video and go back. Polyatomic or ionic compounds. So polyatomic ions are included in the compounds. And it says you need to memorize the following. Well, the following is in the study stack of your Prezi. So that's what you need to go memorize. You need to get to the study stack of your Prezi. And then I'm going to go ahead and just stop the video here and cover the polyatomic ions in another video so that we don't get too much in one video. I will see you soon.